Hi, this is Eric Slack, Senior Analyst with Storage Switzerland. You know, backup is one of those dynamic areas in IT that changes a lot. There's a lot of challenges that are prompting these changes, and we're coming up to another inflection point now currently. And here to discuss this with me is Gideon Senderoff, Director of Advanced Storage for NEC. Gideon, thanks for joining us.
Thank you very much, Eric. Nice to be here.
You know, let me just kind of set the table, Gideon, for this discussion, a little timeline here, just talking about the sort of the timeline of backup. You know, way back when, and it probably wasn't that long ago, we did backup to tape. We moved a heck of a lot of data across networks to, you know, to tape drives and tape libraries, et cetera. And then we came up with disk to disk technologies.
Right.
And we ended up backing up to disk, which provided some advantages to tape backup. And then what came out of that was dedupe backup appliances, and these are disk backup systems that have deduplication, and they've got a change block tracking, which is a way to do incremental change-based backups. They also have advanced compression, but what we've done is we've refined this disk backup technology to really support, you know, or try to support the exploding amounts of data. Well, we're now at another inflection point here in this timeline where this isn't really working anymore because some things are happening that people are dumping on disk backup appliances. Can you talk a little bit about some of the things that are going on and what it's doing to the disk backup appliance market segment, if you will?
Sure, of course. I mean, this is actually a pretty good timeline.
Mm-hmm.
And I think when you were talking about the disk to disk is actually more around things like being able to retrieve things very quickly,
right,
as opposed to going to tapes and getting tapes to come back from a remote location, etc. Mm-hmm. Getting into this, then the cost point was really very cost prohibitive. And that's where we got into things like deduplication and compression appliances. You
mean the cost of buying the physical disk hardware to support all the data that used to be on tape?
Correct. Buying it as well as running it, the operational costs, cooling,
sure.
And footprint, etc. So when we got into this, a lot of the preliminary type devices, and we still see in the market a lot of first generation type, what we qualify first generation type dedupe appliances. That's all they focused on, is how do I reduce this? But nowadays it's actually becoming more of a common feature that's in a lot of different appliances, a lot of different solutions. So we get into what are the other nuances of a system that's going to make it more efficient and suitable for these environments. And in fact, in our case, we actually started with this particular piece from day one, as opposed to just focusing on dedupe.
Our case, you mean NEC's HydroStore?
Correct,
okay.
NEC's HydroStore.
Okay, well, you want to go ahead and tell us about some of the issues then that we're having with this?
Sure, absolutely. So a lot of the data that we see today in terms of what goes into these types of appliances ends up being unstructured data.
Unstructured data meaning file-based data as opposed to databases.
Correct. Correct. So these are things that need to be typically when they're on the main system, they need to be accessed on a regular basis, typically non-transactional. But then you need to be able to store them.
Right.
But so you get into when you get into these types of appliances, you get into backup. But you also have things like archive, and you also have things like long-term data retention.
So what you're saying then is we're now asking this next generation of disk backup appliances to do more than just backup. Is that what you're saying?
Correct.
Okay.
Correct. And those are the areas that we were looking to address in terms of how do we do all of these things, as well as obviously add to that things like disaster recovery. So what are the types of things that are going to be needed in order to do that? And can you actually accomplish this in a system that's going to be able to scale over time? So you get into things like performance. And you get into things like high availability. You get into things like also related to high availability is resiliency of the data. And obviously you get into things like efficiency with a different compression and dedupe, etc.
Well, it sounds like you're describing more of the attributes of primary storage than just a backup device.
That's actually an excellent point, because to a certain extent you can look at these, if you're just looking at the backup portion, then you need just high throughput, and you need to be able to store it efficiently, so you need the reduction. But when you get into other applications like the long-term data repository, at that point you get into how can you create a system that's in essence a pseudo-primary type system that has all the other types of benefits.
Okay.
When we get into things like being able to access it via a file system protocol as opposed to like a VDL protocol, is it also POSIX compliant, for example, and are you able to use it for reference data directly, as opposed to just always going through a backup application or an archive.
So you've got different access patterns and requirements for retrieval rather
Correct.
than for this device that these devices could never do, right? I mean,
Exactly.
Okay, well, can you give us an idea then of if we're really trying to describe what this box is going to look like, can you give us an idea what that would, what the sort of the next generation, if you will, of disk backup appliances would look like?
When we're looking at these types of key requirements, and I mean, we also get into things like, for one over here, when we look at this, is mixed use cases.
Mixed use cases meaning doing what backup and what other use cases? Archive, is that another?
Backup, archive, long-term data repositories,
Okay.
et cetera, and also fitting in the DR.
Sure.
Pretty much most solutions will actually implement some form of DR solution incorporated, but these areas typically are not covered. And the last thing that I didn't mention over here is also modular growth.
Right.
And it goes a little bit beyond that. I'll talk about this in a second.
Okay.
So if we get into performance, these things vary significantly. Because if you look at the backup, you need high throughput.
Right.
Latency doesn't really come into play, because once you get a large backup going into the system, you just need to be able to stream it very fast. You need to also be able to read it readily very fast.
So it's high performance on the input side and on the output side.
Correct,
Okay.
correct. And so that's the key thing. And over here, actually, dedupe comes into play significantly. Dedupe, as well as typically standard compression, will actually be an additional benefit. You can have some specific extra special compression types, compression algorithms, but in essence, standard compression will typically get you somewhere around the 2-to-1, and this is the rule of thumb. People always talk about 10-to-1 dedupe,
How much
2-to-1
reduction do you get?
compression,
Sure.
20-to-1 reduction. When you get into things like archive, now you're looking into, you're not going to get as high of a dedupe.
With archive data, which is written
Correct.
once and typically not modified, so you don't
You
don't
have
a
maybe
lot
different variants, different versions of a
Sure.
file, but they're camped over there. And also archive, that's meant to be the resting place, as opposed to, sometimes people confuse between backup and archive.
Got it.
And they think, well, I'm doing a lot of backups, so that means that's my archive. Well, not really.
Not
and
the same
that's
thing.
Correct. And that's why you also have different archive applications that actually manage it and allow you to do, for example, things like search. And being able to actually things for like legal hold. So those are the types of things over here, but you don't necessarily need the high throughput.
Got
So
it.
throughput is not a concern. Dedupe is not necessarily as applicable. You are going to get maybe 3-to-1 reduction or 4-to-1 reduction, but at that point you're more worried about the size of the system, the cost of the actual disk drives,
Right.
as well as being able to retain it, and then you get into things like the resiliency. Having it available, especially when you're going to retain it for several years, 7 years perhaps even longer.
Excuse me a second. So when you're talking about resiliency, what you're talking about then is the ability of the system to store data for long periods of time and still, without basically having to create another copy and back it up somewhere.
Correct. That becomes your primary copy in
Right.
essence. So resiliency and efficiency. Right. So at this point, there's certain levels of dedupe that will actually get you the same level of reduction as more advanced dedupe, perhaps, but then you can actually get it at a lower cost.
Well, this is not a RAID system, though, right?
Correct. Well, that gets into the whole point about resiliency. That's actually applicable across the board for both backups as well as archives. If something is deduped, for example, now you basically lose all your backups as
Right.
opposed to just a single one. So resiliency, you get into things. In our case, for example, we've always talked about erasure coding.
Right.
Right? And it's interesting. I thought that by now, several years later, I mean, we introduced our implementation in 2007. You figured that more hands in the audience would go up. And still, when I go up and I say, well, who's heard about erasure coding?
Right.
Pretty much nobody raises their
And
hand.
we're talking about erasure coding. What we're talking about is kind of a parity-based technology that eliminates the need to create second copies like you do with replication, or to do RAID rebuilds and RAID sets. Right? It's a
Exactly.
flexible parity-based system. Okay.
A lot of the implementations you see today, especially with like Hadoop, et cetera, they're talking about 3 copies, and some systems actually use that type of a process. So this is an area where it allows you to do it efficiently, but still maintain the same level of resilience.
Okay. So what else does this system need to be able to do then?
So long-term data retention. So if you have a lot of data, right? When we're talking about the backup, for example, if you have petabytes of data that you need to back up, you need the throughput. You need the petabytes per hour performance, right? And this is an area that you can do with a modular approach, being able to scale out the system.
What else does the system need to do? You're talking about having the throughput and being able to move the data in and out of really a potentially enormous system, right? What else does this thing need to look like?
2 things I want to talk about. One of them is getting into the modular growth. When you're talking about having all this data sitting on the system and you're constantly adding more data to the system, at the same time this technology also continues to evolve. And you're starting to double disk drive capacities. And the idea is to be able to not only add components into the system and be able to grow it, but to grow it with newer generation, denser, faster pieces.
Okay, so if you're adding modules to this system, you're saying then that you can upgrade an individual module then with your technology, and it doesn't impact the data that's in place
Correct.
in the system.
And over time, maybe 5-7 years later, when it's time to retire one of the older components, you can do that in place. So you never have to deal with massive amounts of data, petabytes of data, having to migrate and go offline.
Okay, cool. Can you, and you said this is the Hydra Store, can you write that down just so we have an understanding of what NEC's technology is?
Sure.
Okay, great. Good. Well, Gideon, thanks for joining me. This is a great discussion, and we'll look forward to talking to you next time.
Thank you very much.
This is Eric Slack, Senior Analyst with Storage Switzerland, and thanks for joining us.